Hey, welcome back to Math with Patrick. Today is November 26th, and we're solving problem 330 from the Daily Epsilon calendar. And the answer today should be 26 because that's today's date. Seems like today all we're doing is converting this number in binary into base 10. And let's maybe talk a little bit about just bases in general before we attack this number right here. So when we write numbers, say like 562, this 5 represents the number 500. This 6 represents the number 60, and this 2 represents, 2. And the idea here is that for every place we move over to the left, that number, this 6, actually just represents 6 times 10. When we move over the next place, it's times 10 times 10, or times 100, or times 10 squared. And then once we include some kind of place in the thousands, say a 3, that 3 actually means 3,000, and we're multiplying that 3 by 10 cubed. And I think the reason why we count in base 10 is because we got 10 fingers. And this number right here is essentially arbitrary. We don't need to count in groups of 10, 100, and 1,000. We just do. So numbers, say, writing this same number again, could be written in different bases. Like this 2 could still represent the number 2, but maybe our bases say 8. And so this 6 right here represents 6 times 8. This 5 here represents 6 times 8 squared. And this 3 here represents 3 times 8 cubed. And it doesn't really matter what the base is. It's just that we usually do math in base 10. For our number today, we are in base 2 or binary. This 2 right here basically tells me what the base is. And so for this first number, we could multiply by 1. This second number, we could multiply by 2. The next number will multiply by 2 squared, or 4. This number right here will be multiplied by 8. And then finally, 16. One thing to keep in mind, though, with certain bases and arithmetic, though, is if we're kind of in this base 8 scenario again, the number 9 can't exist. Because to represent 9 things, I could represent it as 1, 8 and 1, 1. And this would be the correct way to represent the number 9. In fact, the correct way to represent the number 8 is one group of 8 and nothing else. And so this represents 8 objects in base 8. So when you're working in a base, you'll never see that actual digit show up in any of the numbers. So since we're in base 2, we're never going to see the digit 2 show up at all, because the proper way to write the number 2 in binary is this. So that's just one more thing that I wanted to mention in kind of like other base arithmetic. Here, like since we are converting it back to base 10, I could just think of it as 16 plus 8 plus 2, and then just go back to my old ways of doing math on base 10. Here we have the number 10. Adding it to 16, we do get 26 for today. So it's a pretty short problem, but I just kind of wanted to mention other base arithmetic more than just the base 10 or binary for today. So that's all. Answer is 26. We're all done. I'll see you tomorrow. Bye.